balancing will come once the delta segment is done.
Yeah, but your problem is going to be, here's your problem, is you're going to be setting objectives for the San Joaquin River, and you're going to then have some future water right proceeding. But based on a due process consideration, if the San Joaquin isn't part of phase 2, you got an issue. I mean, how is it? I'll be simple about this. So let's use delta outflow. So currently your process for phase 1 is set up that you're going to look at February through June. So it doesn't have a, and fall X2 is a big issue. You've been hearing about it from workshop 1 till today, and you'll continue to hear about it. We're not in that mix. I mean, and then if you're going to include us in that mix, your analysis for phase 1 would have to look at some probable analysis or expectation of what you think you're going to get out of the San Joaquin River for phase 2, because it's the point I pointed out earlier in our submittals. If the impact is, let's say, 500,000 acre feet of additional water February through June, and that's your quote project, but it's really not your project because you're going to come back in the fall and try to get another 100,000 acre feet, well, you got a segmenting problem. And that's the problem that I've pointed out, is that when you do the analysis, it's going to be two different things. And then how are you going to do that? How are you going to do that from understanding the impacts within the basin? And that doesn't include other flows that may be happening, as we pointed out to you under the biological opinions, that aren't included in the analysis as well. Because see, when it was all done together.
Tim, slow down.
Sure.
Listen to what listen to what you're presenting here. I mean, you're essentially laying out as strong a case, I think, as you can make, that we're just silly to be sitting up here listening to anybody about anything. This can't work, and that's we're just not. We're not
I'm not
here
saying that at all. I'm saying the problem is you segment. Look at the old basin plans were done in their entirety. How is it that you're going to understand what the impacts from a fall X2? So if you want 100,000 acre feet from the stand, and you've already taken 100,000 acre feet in this phase 1, how do you document that in phase 1 or in phase 2, and then come back and do a water right based on that? That's my problem. I'm not saying you shouldn't do anything or you can't do anything, but it's a procedural aspect that you have to look at on how you get from here to there. And quite frankly, the segmenting is going to cause you major problems. If I'm a downstream guy, if I'm the SWP or CVP, I'm thinking, why is the San Joaquin River getting a hall pass for fall X2? Because we should be part of that process. OMR flows. How do you do OMR flows if you don't have San Joaquin River flows? But if you're going to basically say that these flows are the flows that are it, then you got a hard problem documenting it. That's all I'm saying. You can do it. I don't think it'll be supported, but you can do it. Any other questions? Thank you.
Somebody from Fish and Game have a short rebuttal or anything?
We don't have the opportunity for rebuttal here. I don't.
Darn.
Brock, I assume we're on the in-Delta folks now, or do you?
Yes, that's right.
Okay. We switched things around so much I couldn't.
We're back on the original agenda, but just a little bit further along in terms of time. So it's Susan Paulson.
Deb's going for a walk.
Okay. That's on it.
I'll buy.
All right. It looks like I'm the sole representative for the in-Delta interests today. I don't know what happened to the
You've
rest.
worn the rest of them down, Susan.
Well, my name is Susan Paulson. Thank you very much for the opportunity to be here. Is there a, how do I, sorry. Oh, there it is. Okay. I'm here on behalf of the City of Antioch today and would like to focus primarily on the hydrodynamic and water quality aspects, some of the considerations that you may be thinking about in developing Bay Delta criteria. And I'd like to focus primarily on 3 recommendations that the city would make. One concerning the operations modeling and validation of that modeling. Another that focuses on the importance of the source of water at any location within the delta. And then the impact of both sea level rise and new habitat and how we use models to evaluate those things. And then finally, I would like to reiterate the city's requests, the specific requests that the city has made with respect to the Bay Delta plan. All right, the first recommendation has to do with the operations modeling. Most operations modeling and the modeling done, for example, as part of the BDCP process, is reoperating a historic period of hydrology. So they're taking, for example, calcium 2 here is being used for an 82-year period to reoperate the hydrology that occurred within that period, but using the operating rules that apply today. The main concern that we have with that approach is that there have been a number of very significant changes, as you are all aware, that have happened after that 2003 period. So even though the operations modeling is simulating those changes, we aren't actually modeling the period for which those changes apply. So we don't have model results from calcium 2 or the other calcium 2 to simulate those changes that have occurred since 2007. So even though those are being superimposed on the old hydrology, we aren't able to validate the model or to confirm that it is simulating the current conditions accurately. Some of those changes that are important are changes to the amount of flow that is exported from the delta and changes in flow requirements, like the OMR flows, flow requirements that are internal to the delta. So the city's recommendation would be that calcium 2 be used to simulate operations for that modern period of 2007 to present, and DSM-2 be used to simulate the conditions in the delta so that we can establish that these models accurately represent those conditions. Right now, I think the models are frequently being used to compare one scenario to another, but we really don't have that confidence in their ability to model that specific current condition, and that's our baseline. That's what we're operating from. The second recommendation, and there's a series of slides pertinent to this recommendation, would be that it will be important to evaluate the source of water within the delta. It's pretty easy to tell the difference between freshwater and saltwater. A conductivity meter will do that. But it's much harder to tell the difference between 2 sources of fresh water. And those 2 sources of fresh water might have very different quality. To echo something that Tim said just a few minutes ago, even though Antioch is in the western delta, it's physically located on the map on the San Joaquin River. But the water that they pull in at that intake typically isn't San Joaquin River water. A very, very small fraction of it might be San Joaquin River water, but mostly it's Sacramento River water. And that's because the water mixes so completely through the system, and so little San Joaquin River water makes it out to this part of the system and through to the bay. I'll show you a little bit of that. The models can also simulate not only the water source, but the residence time of water within the delta, and that's important for quality. So what I'd like to talk to you about is some work that we did quite a long time ago, roughly 15 years ago, where we used the geochemical fingerprints of the 2 rivers and of the bay to tell where water collected from the interior of the delta had originated. So we did that using daily composite samples that we collected over, well, the period I'm going to show you is roughly a 9-month period. We did find that very little San Joaquin River water reaches the bay, but we were also able to make some conclusions about the source of water interior to the bay. Now this map is just for reference. It shows a few of the locations that I'm going to talk about. You can see, I don't think I can point. Oh, I can point. Antioch's intake here on the San Joaquin River, just the confluence of the 2 rivers is also in this area. Sacramento River flows in from the north. The San Joaquin, sort of hard to see on the satellite photo, but flows in roughly on this pathway. We gathered water samples interior to the delta at Bethel Island, which is adjacent to Frank's Tract, and at Clifton Court Forebay, which of course is one of the export locations. I'm going to talk later in the testimony about these 2 locations, Edmonton and 3 Mile Slough as well. Now, the graphs that I'm going to show you here are the results of those water samples and the analyses that we conducted using water samples collected from within the delta. So here you can see on this axis the time frame from roughly April of 1996 through the end of 1996. And each bar is 1 day's sample. And this is showing results, fingerprinting results at Clifton Court Forebay. What you see, let's see if I can get this to move this, sorry, it's sticking. Let's just take this period. The blue bars show that during that time period, on average roughly, I don't know, 85, 90% of the water that was present at Clifton Court Forebay had come from the Sacramento River. The remaining 10 or 15% had come from the San Joaquin River. And there are some very small green bars up at the top. They're very hard to see. There is a small fraction of bay water that's carried in on the tides. Now, this fingerprinting analysis assumed, just mathematically it had to, that these three sources, the two rivers and the bay, contributed 100% of the water at that location. And that's not actually a bad approximation. It's probably 85 to 90%. We'll see how that compares with some other results in just a moment. At at Bethel Island, as you move farther toward the bay, so Bethel Island is sort of by that Franks Tract area in the central west part of the delta, you can see that the Sacramento River comprises most of the water, on the order of 90% of the water at that location. San Joaquin River is maybe 10%. And then here, as you'd expect, because it's closer to the bay is a more important contributor to the water at that location. One interesting feature, if we go back to the one at Clifton Court, you can see a slug, if you will, of San Joaquin River water that moves through the system here. That's when the interior delta barriers were removed that year. So they raised the water surface elevation. When those barriers came out, the water that had been held behind those barriers flowed out of the system. And you saw some San Joaquin River water flowing through. It made it to Clifton Court Forebay, and you can see, even though we were missing some data in here, it made it out and past Bethel Island as well. Now, the reason that the source fingerprints are important is because the water source is an important determinant of water quality. Obviously, if you get bay water, you know the salinity goes up. But you've learned, too, with this work, that the San Joaquin River is an important source of salinity interior to the delta. The San Joaquin River also has a higher concentration of some other constituents, pesticides, selenium, things like that. When you take the source fingerprinting work and you look at the source of salinity in the delta, this is the same kind of a graph, same time frame, roughly, on the bottom axis. The open dots are the concentrations of sodium, which is a surrogate for salinity, that was measured at Clifton Court Forebay. So these are the actual sample results from Clifton Court Forebay for this whole time period. The bars that you see on the bottom show from the fingerprinting analysis where that salinity came from, where that sodium came from. The blue bars on the bottom, they look black here, but the blue bars on the bottom are the Sacramento River. The pink is the San Joaquin, and the green is the bay. So even though there was a very tiny fraction of bay water present, it contributes a fair amount to salinity. The San Joaquin River, if you'll recall, was on the order of 15% of the water at this location, but over the long term, it contributes on average 50% or maybe even more of the salinity at that location. And the Sacramento River, obviously, is lower salinity, higher quality. So it's the bulk of water at the location, but it contributes the smallest part of salinity. So that's Clifton Court Forebay. When you move farther into the delta at Bethel Island, the salinity goes up. Again, the open circles are the actual daily measurements of sodium at that location, and the bars are the source. And clearly, the bay is a much more important contributor, or was in this time period, to salinity at this location. But even early on, when the bay wasn't such an important source of water, the San Joaquin River contributed probably 50% or more of the salinity at this location. Now, when you pair this with the other things that might be carried in San Joaquin River water, you can see why the city of Antioch would be concerned about the source of water at its intake. And the city anticipates the BDCP preliminary results that we showed you a couple of workshops ago showed that the salinity at the city's intake will likely increase as a result of BDCP, even in the absence of sea level rise. And those effects were most pronounced in the BDCP model results for wet and above normal years and for the fall months. The other reason that we have done this fingerprinting is to validate the model's ability to determine the source of water. And I'll show you that in a moment. They do really quite well. The other point I'd like to make is that the models can simulate the residence time, the length of time that water is present in the interior of the delta. As the residence time goes up, other things can happen, like you can get higher water temperatures, higher algae levels, lower DO, as the water takes longer to flush through the system. So the flushing time goes down, the residence time goes up. So the models can be used to demonstrate that. Now what we did was to use the models. The results I'm going to show are for the Fisher Delta model, but results for the DSM-2 are similar. We used the models to predict the source of water at these two locations where we had the chemical fingerprints. So what you see in the large part of the slide is the fingerprint, the source water results from the model. And you can see they're fairly similar to what we saw with the chemical fingerprints. You see the slug of San Joaquin River water moving through. You see that the Sacramento River, is the bulk of water that's present at that location. And you can get an estimate of how much water comes from other sources on the order of 10, 15, maybe up to 20% or so in a few small periods.
Susan, you're
Yeah.
the statistician, but is there a reason why you're using 16-year-old data instead of more current data?
Well, because nobody has duplicated that I know of, the chemical measurements. So we use those measurements from that period to validate the models. The models are then used to establish the fingerprints in the source of water for a much broader period of time. So what I'm trying to show you here is that the models are suitable for this purpose. They've been validated using actual field data, and these are the field data that we have, and therefore that we can have confidence in those models to predict the source of water in the delta for a wide range of conditions.
I didn't ask you that caustically, I was just curious.
Yeah, because they're the data we have, frankly,
Okay.
is why. And because I think that, well, I hope they illustrate that the source of water can be important to salinity, to water quality, to residence time, and the other things, temperature, algae, that can happen interior to the delta. So,
And,
Yes.
and you would also say that if conditions were to change so that the mix was different, that your model should be able to accommodate that change.
yeah, well, we clearly have some recommendations for how the models can be improved and would like to establish that they are simulating current conditions accurately. But provided we can establish that, yes, absolutely. We do have confidence in the ability of the models to show these things. Here's the same kind of thing at Bethel Island, again, a pretty good model validation that the models can simulate these things accurately. And the reason that we think that this kind of analysis is going forward, because as we've seen, BDCP proposes to divert Sacramento River water from the northern part of the delta. So that's removing some water from the system before it would have been under current conditions, so that Sacramento River water, which is lower salinity, typically higher quality, won't make it through to the South Delta, to the West Delta, to the Central Delta, at least not in the quantities it has in the past. And that has potential implications on water quality, both at the city's intake and within the interior of the delta. So if we're removing water from the system and decreasing the flushing times, we have the potential for the water quality interior to the delta to worsen as the residence times go up and as the flushing times go down. So it's not just salinity, although that is clearly the city's primary concern at their intake, but it's all these other water quality factors or conditions that can be changed as a result of changes in the delta. And frankly, that you have quite a bit of ability to control, to evaluate in establishing criteria for the delta, objectives for the delta. So I guess the city's request is we would ask the state board to consider the source of water, the water quality impacts, and the changes in residence time that could occur as changes are made to the delta and or as changes are made to the objectives that govern quality in the delta. All right, and just one slide for the third recommendation. This is a quick one. We made this point in workshop 1, but I think it bears repeating. Depending upon the location and the design, habitat even interior to the delta can increase salinity in the western delta. Basically, as you increase the habitat interior to the delta, you increase the volume of water that's in the delta and the volume of water that would move in and out of the delta on a tidal cycle. So that has the potential, again, depending on the design and location, to increase salinity in the western delta. The second concern with relation to habitat and sea level rise is that the water quality models that we're using, DSM-2 and the like, typically retain the current channel geometry when they're simulating these future conditions. So they may not accurately simulate the effect of shallow habitat if you're assuming essentially vertical walled channels, but you're in actuality flooding some of the area adjacent to those channels. That's not necessarily captured by the models now. And then over the long term, if you create habitat interior to the delta, you're also likely to change erosion and deposition patterns. So the city's request there would be that these effects, both of habitat and sea level rise, be evaluated in a robust manner, and that the models be adjusted as necessary to capture shallow water habitat and some of these other factors. That these factors be evaluated over the life of the BDCP or the proposed change in objectives. And then in conclusion, I'd just like to reiterate the city's requests from Workshop 1, that salinity should not be allowed to rise nor outflows decline beyond current levels as established by D1641 and X2. Here's where the map comes back in. BDCP had contemplated a move in the compliance points from Emmetton inland to 3 Mile Slough. It looks like a small distance on the map, but it potentially has significant impacts for salinity in the Western Delta. So Antioch would request that that compliance point change not be allowed. That the city is a key point of interest for water quality and salinity in the Western Delta, and the city requests that the State Board consider using its gauging station as a point of interest for flows and salinity at that location. And then finally, to ensure that mitigation is provided for impacts to beneficial uses like the domestic municipal water supply that may occur as a result of BDCP or other future changes in the Delta. Thank you.
Thank you, Susan. Any questions? Thank you very much.
Charlie, we're actually back on schedule, so if you want to take the scheduled break and start again at, say, 10:45, we'd be okay?
Fine with me. Thank you. We'll begin at, resume at 10:45. Thank you, Dr. Paulson.
My testimony cites a DWR study. It's the low-head functions. And it confirms, I just want to make you aware that in case you're building a case with your client, DWR did a study based on salinity violations in the Salmon that, among other things, traced the source of the salinity of the source waters. No, this was strictly a salinity-based study, that particular. And I just wanted to make you aware of it.
I'm first, Ted. I'm sorry, just because you moved in here doesn't
Look
mean
at
you
my
can talk to her first.
testimony, because I'm pretty sure I provided a hyperlink to it.
They had it.
Yes, it's in the, it'll be in the workshop one written testimony.
Where are you?
Well, it's slightly different in that, what's different about mine is it's focused on south.
I would agree with all the I'm just saying, if they want, if they have an
All that DWR shows is the vast majority of the flow and channels leading from southeast to so if it turns out it's further confirmation. It's also a series of
well, it's simpler runs better.
I don't know. I don't know. It's just not
When it comes to the dance,
Whole work has to go.
right? Good work.
But Fisher,
Actually, I just want to know, do you have any additional data during that time span? I've done the nutrient modeling, and right.
He says right. You're talking about diet, right?
So well, strontium, I guess, would give you.
I have a question. Sure. In terms of your presentation, I understand the significance of the importance of finger pointing. Obviously, for me, or maybe that's obvious, that representing west side, the data from '96 is essentially irrelevant at this point in terms of salt contributions from the San Joaquin or from the west side.
Well,
It
certainly
would
things have
change.
changed, but the point that I wanted to make was not, sure, I don't know to what extent. I mean, we haven't gone out and reanalyzed.
And have you, I thought DWR presented fingerprinting with data more recently.
That's why I wanted to give you this.
Cool.
I put our website on the back.
Okay.
The Real-Time Data and Forecasting Project. We get fingerprinting products from the Bay Delta office in DWR that we
Right,
put
but
on.
those are model results.
Right, but our group also has anion analyzers at Clifton, well, at Banks and at Vernalis and at Jones. And we more or less corroborate what you presented here. The San Joaquin gets sucked in.
In terms of quantity, I get, or
Volume percentage.
but what about salinity?
Right. And the modeling group gives us modeling products that show volume, salinity contribution, dissolved organic carbon contributions at fingerprint results at these different sites. And they more or less corroborate what you've just presented, but for modern, we're continuing to do this more or less every month. And
Well,
I
and the
just
point of this
wanted
wasn't
you to
that
be
this is
aware
the way
that
things
this,
are now.
this
It's
product
just
is available.
you know, it's a model validation. I
And-
am generally aware of that.
DSM-2 generally underestimates the salinity contribution at Clifton Court and therefore as well at Jones as well.
Well, and there's problems in the rock blue area
because,
through that stretch.
Because Frank's track acts as a tidal pump a little bit more strongly than the model, the DSM-2 model can get, because it has a hard time treating a large water body.
But the salinity makeup at Clifton Court has to be different today than it was in 1996.
Right, but the point is not to say that it looks like this today. The point is to say that the models can do this. And it's an important consideration.
And that's what I was telling Charlie.
And
Yeah.
Is in terms of the importance of fingerprinting, I can understand. The importance of modeling to understand salt contribution, I can understand that as well.
Yeah.
Yeah.
That's, and maybe I didn't make it well, but that was the point I was trying to
You
make.
hit on more of a sensitive and this idea.
I found
and your
your-
point, but your point,
reactive, are you?
well, your
the
point,
soft
but
spot.
I mean, it's particularly because and I agree with you. You have a criticism about calcium, and frankly, my thought is the same criticism that you made on calcium holds true with the second part of your presentation, and I appreciate what you're saying to me now because now it's consistent. But the idea that your calcium's not looking at recent data, and then you look focusing on 1996
Well,
raises
but-
the issue. But
I mean, frankly, this was
that's
a proof of concept in terms of geochemistry. Are these rivers distinct? Do they have unique geochemical fingerprints? And they do. They clearly do. I mean, the Sacramento's, kind of a granitic, I don't know, traditional whatever. The San Joaquin is this marine shale, high selenium, molybdenum, vanadium, uranium, rare earths. It's just got its own funky composition.
Yeah. Richard Denton is doing a more thorough analysis of all the ionized data he can get from all the graph sample data that our group's produced to come up with better regressions of, rather than just saying everything's got the same regression with EC. And he'll be producing his report pretty soon.
Yeah, and that's important. I mean, the
And
conductivity,
sure enough-
all of the ions have different specific conductivities. They all contribute differently to the salinity
Well,
signature that you measure.
and it depends on what season, it depends on what your season you're talking about, whether the EC is EC from Martinez or EC from San Joaquin.
I didn't know if I was supposed to bring my own or not.
So we've have a look at our website and look around and give me a call if you want to talk about it.
I will do that.
Yeah.
Yeah, definitely.
It's,
Oh,
yeah, you're
okay, so.
getting at the fact that water quality is different.
That'll confuse me.
Yeah.
Can you use a roller to go back?
Had it knocked in.
That was
Yeah.
I don't think there's anything you couldn't do. Okay. Anyway, it's a pleasure to see you.
Ladies and gentlemen, if you'd take a seat, please. How are you feeling, Mr. Vogel? You feeling better?
Yeah.
Good. Mr. Hitchings, are you going to introduce Mr. Vogel here, or tell us
Yes,
what to
if that would
believe
be
and what
okay.
not to believe, or how are we going to do this?
Yeah, just a brief introduction, if that's okay. Good morning, Chair Hoppen, members of the board. My name is Andrew Hitchings on behalf of the Sacramento Valley water users. Just want to provide a brief introduction of Mr. Vogel and his presentation, which will follow. First of all, as you may recall, Mr. Vogel was unable to present at the workshop 2, so we appreciate the board's accommodation for him to make his presentation today. Mr. Vogel is a fishery scientist with nearly 40 years of experience. He previously worked for Fish and Wildlife Service and NIMS for 15 years, and he's conducted Anadromous Salmonid studies in the Central Valley for over 30 years. His presentation is going to focus on Salmonids and address the following questions that were framed in the board's notice for workshop 2. So we felt it's important to get everybody framed back for that workshop for these questions since we're in the middle of workshop 3. Those questions were, what additional scientific information should the board consider to inform potential changes to the Bay Delta Plan related to Bay Delta fishery resources, and specifically pelagic fishes and salmonids, that was not addressed in the 2009 staff report and the 2010 Delta Flow Criteria report? What is the level of scientific certainty or uncertainty regarding the foregoing information? What changes to the Bay Delta Plan should the State Board consider based on the above information to address existing circumstances and changing circumstances? And then the other set of questions in the board's notice, which Mr. Vogel will be presenting on, are how should the State Board address scientific certainty and uncertainty and changing circumstances? What kind of adaptive management and collaboration, short, medium, and long-term monitoring and special studies programs should the State Board consider related to Bay Delta fisheries as part of this plan update?
He's going to do all this in an hour?
50 minutes. So with that, I'll turn this over to Dave. Thank you.
Mr. Vogel, I thought it was very interesting. It was unfortunate you were unable to attend the scheduled board meeting, but generally when we try and bounce things around, one side or another thinks that's not a good idea, and I didn't hear anybody complain about having you have the opportunity to speak today, so I think that speaks to your credibility. So.
Thank you very much, sir. And I do want to echo Andy's
Your microphone?
gratitude.
The green light.
I do want to echo Andy's comments. I'd personally like to thank the board staff, and Brock for accommodating my change in schedule to be here today. And therefore, I'll do my best to make this presentation informative and worth your time. Much of my written submittal to the board was derived from a technical report I wrote last year on behalf of Northern California water agencies. Much of the information in that report was derived from my research on Central Valley and Anadromous fish since 1981. These are the summary points of my presentation today. First, I'm going to talk about salmon restoration progress in upstream areas. Then I'll move to the point about the need to fix predation problems in the Delta before we can fully realize the benefits of the upstream actions. Third, I'll talk about the concern about potential high unimpaired flow criteria impacts to salmon in the basin. And last, and probably most importantly, I'll recommend actions and studies to benefit salmon. Moving to the first topic, there has been remarkable progress on salmon restoration in the Sacramento River Basin. Today, I'll provide some highlights of some of the most successful of those actions. At one time, Red Bluff Diversion Dam on the upper Sacramento River was considered the largest salmon killer in the entire basin. I conducted 10 years of research when I was with the U.S. Fish and Wildlife Service at this particular dam. Incrementally, over the last 2 decades, the problems for both upstream and downstream migration of salmon at the dam have been eliminated. In the mid-1980s, my diving crew and I mapped the entire riverbed from the city of Redding all the way up to Keswick Dam, which is the upstream terminus for salmon migration. We used techniques I developed from working as a volunteer for the Sheriff's Search and Rescue Team looking for drowning victims in the Sacramento River. What we found in that cold, swift, deep water was that some habitat remained, but by far, most of the habitat had been scoured away down to bedrock. As a result of those surveys, the Department of Fish and Game and I recommended that the Bureau of Reclamation initiate very large-scale gravel injection problems just downstream of Keswick Dam. Ongoing evaluations of that project have demonstrated it to be very successful. These gravel additions have greatly improved the quantity and quality of spawning gravels in the coldest reaches of the main stem Sacramento River for salmon. At one time, acid mine drainage from the abandoned Iron Mountain mine on the upper Sacramento River caused major fish kills. I served as the task manager on behalf of EPA for this multi-million-dollar Superfund site. Long story short, that problem has been essentially eliminated for salmon. Water temperature problems for salmon in the Sacramento Basin have been aggressively addressed. Beginning in 1987, the Bureau of Reclamation began bypassing the power plant on Shasta Dam over the spillway and through the spillway to access the coldest water deep in the reservoir to benefit salmon spawning. Beginning in 1997, use of the temperature control device installed on the face of the dam has been used every year to improve thermal conditions for salmon spawning in downstream areas. These measures have greatly expanded the range of suitable spawning habitats for salmon 60 miles downstream of Keswick Dam, and also has provided added protection for salmon during drought years. In 1986, the Department of Fish and Game and I developed a 10-point action program to develop protection for winter-run Chinook, now an endangered species. Remarkably, nearly every one of these major projects has been successfully completed. Each of the primary tributaries from small to large also has major success stories. I'm not going to go through each one of these. You could spend all day talking about any one of them, but I will point out that they are discussed in our written submittals. Remarkable progress has been made in the tributaries of the Sacramento Basin. In recent years, there has been a proliferation of groups promoting restoring the health of Sacramento Basin watersheds. Incrementally, over recent years, conditions for fish in these tributaries has been significantly improved. I don't believe there's an existing agency salmon restoration program that has not identified unscreened water diversions as a major problem for anadromous fish. All of the largest diversions in the entire basin have now been screened with state-of-the-art fish screens, and many of the mid-size and smaller diversions also now have new fish screens. The photo at the lower left in this slide shows the new Glen Calouse Irrigation District 3000 CFS fish screen. On behalf of state and federal agencies, I served as the biological study team leader evaluating this new facility, and we found those fish screens to be highly effective in protecting fish. In the summer of 2008, under contract with the Anadromous Fish Restoration Program, my company conducted a detailed survey of every single unscreened diversion between Verona and Red Bluff, a distance of more than 160 river miles. This project is part of an ongoing effort by the state and federal agencies to identify the most important remaining sites to install fish screens. As part of this program, my company is also working for the Anadromous Restoration Program to evaluate entrainment of salmon into unscreened irrigation canals. At selected sites by the state and federal agencies, my field crew samples all of the flow 24 hours a day during the entire irrigation season from April through September. To date, no large impacts on juvenile salmonids has been observed. Given this remarkable progress on salmon habitat restoration in upstream areas and expenditures of over $1 billion, it begs the question, why have we not seen dramatic improvements in the salmon populations? I attribute much of the problems to the Delta. The Delta is largely a bottleneck for juvenile salmon survival. Now, that's not to say that there clearly are additional projects necessary in upstream areas, but until the delta is fixed, much of the upstream progress will be negated in the delta. So what kills juvenile fish in the delta? I believe it's primarily non-native and native predatory fish. But why is this a problem? Because the predators and salmon have coexisted for many years. I'll make the argument here that habitat conditions in the delta have evolved over the years, favoring predatory fish over juvenile salmon. You might notice I snuck in a couple family pictures here. I'll provide some insights to support that premise. Over 15 years, I conducted 22 different studies in different parts of the delta to study juvenile salmon migration and predatory fish migration. The green shaded areas on the map shows the various regions my crew, using 2 different jet boats, have traversed many, many times over the years studying where those fish migrate. Salmon migration was evaluated using 2 types of technology, radio telemetry and acoustic telemetry. Each of those technologies has its own advantages and disadvantages, which I won't discuss here, but I'll emphasize the point that these new tools have provided much more valuable data that was previously unavailable. I also utilized a new high-tech sonar camera originally developed by Homeland Security. This particular type of camera can see through the murky delta waters up to 90 feet away from the camera lens. Some of my footage is available for viewing on YouTube. 12 years ago, some of the original radio telemetry studies I conducted were at the Delta Cross Channel in Georgiana, Slough. Although these fascinating results have been presented by me at many times at various science conferences such as IEP and Asilomar and CalFed, the project sponsor, never funded completion of those reports or completion of the projects in the form of final reports. That's a real shame. In larger scale research, funded by the U.S. Fish and Wildlife Service, I found that radio telemetered smolts migrated many, many miles every day with the twice daily flood tides. Upon encountering the confluence with Cache Slough, many of those telemetered smolts were advected back up north into Cache Slough near Liberty Island due to the large tidal prism in that particular region. On the San Joaquin side of the system, telemetered smolts that entered channels south of the delta rarely re-emerged back into the San Joaquin River. In fact, one of our radio tag fish was found live at the federal Tracy fish facilities in the South Delta. An unexpected benefit for many of these studies is we could determine where fish were eaten by predatory fish. 7 years ago, under contract with DWR, I conducted the first beta test of a new technology, miniaturized acoustic telemetry. The initial hope was if we released individually identifiable acoustic-tagged salmon in the lower Sacramento and the lower San Joaquin, and we placed acoustic receivers at strategic locations throughout the delta, we could track the fish migration and the fish survival all the way to Chips Island in the western delta. This technology became the new research tool du jour. However, during one acoustic telemetry study, I made an amazing discovery. During post-processing, each of the fish records a visual echogram. 3 examples are shown here. I found that 3 of the salmon we released in a particular study at an upstream area at different times and locations reached a downstream receiver at the exact same second, and thereafter moved in perfect unison for hours. The conclusion? All 3 fish were in the stomach of a single predator. In this case, it was likely a straight bass. As a result of that finding, I went back and reevaluated the telemetry data for that particular study. My original estimate of 100% salmon survival was now changed to 100% mortality. Here's the problem. When acoustic-tagged salmon is eaten by a predator, and then that predator subsequently swims downstream past an acoustic receiver, we erroneously assumed that the tag was emanating from a live salmon, not a dead salmon inside of a predator. With this incorrect assumption, salmon survival models would be biased high. Now here's where it gets really interesting. Intrigued by this problem of the inability to differentiate between live salmon and dead salmon inside of a predator, DWR and the VAMP agencies funded me in completely different studies in the North Delta and the South Delta to tag adult striped bass with acoustic transmitters and study their movements. Now, if these fish remain relatively stationary in the Delta, our original assumptions on the survival models, models would not be biased. However, that was not the case. Many of those acoustic tagged striped bass moved many, many miles throughout the Delta, often moving far westerly past our receivers at Chips Island. Despite this major setback in the technology, I found an enormous ancillary benefit of the technology. Again, looking at the visual echograms during post-processing, we could determine if the transmitter was moving or not moving. The transmitter on the top shows no changes in amplitude and voltage, signifying that the fish was either dead or the transmitter had been defecated by a predator. This scientific breakthrough led to the discovery of certain regions in the Delta where tags or dead fish accumulated, such as this particular site near a railroad bridge on the lower San Joaquin near Stockton. We also found numerous other sites where transmitters accumulated, such as sharp river bends near pump station intakes, docks, marinas, and bridge piers. Based on the VAMP studies I conducted over several years, I found that the two largest hotspots, based on the telemetry data, were immediately behind the Clifton Court forebay gates and immediately in front of the Tracy Fish facilities. Another location where unusually high rates of predation may occur are at levee breaches in the Delta. This particular site shows levee breaches in southern Liberty Island in northern Cache Slough. As part of a predator study I recently completed for DWR, we tagged adult striped bass, shown by the white dots in this graphic, in northern Cache Slough. Zooming in, the white dots show in this graphic where we captured many of those striped bass. Due to the narrow levee breach, there's a very large, deep scour hole that creates ideal conditions for predation on juvenile salmon as they are swept in and out of the flooded Liberty Island with the flood and ebb tides every day. Incidentally, striped bass anglers are frequently seen fishing at this site. Another area I believe is a hot spot for juvenile salmon predation is at a pipeline on the Sacramento River near Freeport, just south of Sacramento. I used sonar camera footage at the site, which is available for viewing on YouTube, and it revealed large numbers of striped bass residing on the riverbed immediately behind this pipeline that's positioned perpendicularly across the river channel. Again, as you can see in this photograph, this area is extremely popular with striped bass fishermen. Notably, this particular area is important because the entire production of the whole Sacramento River Basin, including its tributaries, has to pass this particular site except during periods when the Yolo bypass is flooding. The take-home message is this: predation in the Delta is not uniform. It occurs at highly localized sites possessing abnormal conditions favoring predatory fish. Now I'll move on to a different topic, the topic of the timing and magnitude of flows for salmon. In the first workshop, the board was provided with extensive information concerning the risks to salmon associated with high unimpaired flows. MBK's report provides substantial information to support this concern. The primary biological problem, from my perspective, is the concern over loss of cold water storage in many of the major upstream reservoirs. You've already heard this point many, many times here in these workshops, so I'm not going to belabor that point, except I'm going to provide you with a real-world example of that concern. Back in 1976 and 1977, Shasta Reservoir reached very low levels, and much of the cold water storage had been depleted. The winter run that were spawned in the river gravels during those particular years basically were poached or they were cooked due to lethal water temperatures in the upper reaches of the river. Because salmon primarily return to spawn every 3 years, look what happened 3 years later in 1979 and 1980. The return was dismal. Again, 3 years later, in 82 and 83, that adverse effect was propagated forward in time and continues to propagate to the present day. I simply put that on there to show you that that bump is largely attributable to the artificial production from Livingston stone. The message is that depletion of cold water pools from these large reservoirs is a very real biological concern. In workshop number 1, Northern California Water Agency presented a report that describes the mandatory in-stream flows downstream of all the major Sacramento River Basin dams. The point I would like to make is that those in-stream flows were developed by the fishery resource agencies and the water project operators based on site-specific conditions in each of those rivers. Each river has its own unique characteristics, and the standard setting flows already established are already tailored based on the different biological needs in each of those rivers. Now I'd like to talk about a different concept, the idea about pulse flows to benefit juvenile salmon outmigration. I'm going to show you 5 graphs that shows a general relationship of how Sacramento Basin respond to natural pulse flows in the watershed. The data I acquired here is from Fish and Game's fish trapping data at rotary screw traps near Knight's Landing, just upstream the confluence with the Feather River. They've been conducting this successful project for many years, provides a very scientifically robust data set. And those data are shown by the large black vertical bars on the left side of the graph. The river flow is data obtained near Grimes, which is the nearest upstream gauging station to compare flow and salmon outmigration. Here's a wet water year. As you can see, with the initial winter storm pulses, we saw a large surge in salmon outmigration. By June, salmon emigration is essentially over. Moving on to an above normal water year, you can see a similar phenomenon. Again, migration is largely over by June. Now moving to back to a below normal water year. Same circumstance. I point out here that we see 2 different types of outmigration. Wintertime outmigration of salmon fry, primarily fall run, but also the immigration of smolt-sized fish such as winter run, spring run, and late fall run. And then in the spring months, April and May, we primarily see the outmigration of fall run smolts, much larger fish. Fry are about 1.5 inches long, smolts are about 3 inches long. And it's also the time period when most of the hatcheries in the basin release their fish. Moving to the dry year, again, you can see that relationship. And lastly, it's also very evident, as you can see, in critically dry years. Okay, now here's something different. Here's something that actually occurred. We have data on this. This is the pulse flow that benefited salmon. In 2003, Coleman Hatchery, located on Battle Creek on the upper Sacramento River, was able to release their entire production of 12 million fall run salmon smolts during precipitation events and just prior to significant river flow increases and also importantly flood control releases from Shasta Reservoir. Point out the dark bar there are Keswick Reservoir releases. The blue line are stream flows at Bend Bridge, about 50 river miles downstream of Keswick Dam, and the dotted line shows river turbidity recorded at Bend Bridge. So I went back, looked at the historical records of the hatchery. Remember I said the fish return every 3 years. In this case it's 2.5 years because the fish are migrating out in the spring. And look what I found. 2.5 years later, Coleman Hatchery observed the largest historical return on record, enormous return. Now people have suggested, well, that's largely attributable to changes in hatchery operations, so I also looked at the combined return to both Battle Creek and Coleman Hatchery, and it turns out In that particular year, it was the second highest return. Obviously, conditions for salmon outmigration in 2003 were very favorable. So what can we do when we don't have these large natural flow events? I'd like to introduce the potential concept about pulse flows without natural events to help stimulate salmon outmigration. Here's a real-world example I conceived of and helped develop back in 1985 when I was with the U.S. Fish and Wildlife Service. The Bureau of Reclamation, over a 3-day period, bumped up Keswick Power Plant capacity up to the flow at Keswick Power Plant, which was about 14,000 CFS, it's 15,000 now, just prior to the release of the remaining portion of Coleman hatchery production. The thing that was remarkable is that that sudden surge in reservoir releases mobilized fine sediments in the river, and the combination of both the high flow and turbidity resulted in a marked jump in migration of both wild and hatchery fish from the river.
Mr. Vogel, can I ask you a question on that?
Yes.
Where it was only a 3-day period, it's hard to imagine that this thing was like a tidal wave going all the way through the delta, I would think is this.
It attenuates. Yeah, it attenuates the further downstream you go. Yeah, if this, for example, 50 river miles, I've plotted that in a result or a report I did for the Bureau back in 1985. When you're around Red Bluff or 60 miles below Keswick, it's a very sharp bell-shaped curve, and we get even further downstream that attenuates to you got a very wide bell-shaped curve. The salmon migration monitoring at Chips Island conducted by the Fish and Wildlife Service trawls saw that same attenuation. Very sharp and peaked early on in the upper river. They get to the delta, very protracted, but still that bell-shaped curve.
But was part of the positive effect that you had such a concentration of fish going through the delta, there was just more than could be eaten, so the mortality was less? I mean, I can see how this 3-day surge got them to Knight's Landing or Sacramento or someplace along the way, but what was the phenomena that, you know, got them through the delta and resulted in this high return? I'm a little bit confused about that.
Excellent point. At that particular time, unfortunately, the delta cross channel gates were open. The biological opinions weren't in place. It was a whole different paradigm in how water management was operated. In fact, the Bureau, I believe, purposely recaptured, I believe it was about 50,000 acre-feet of water in the delta. So much of the benefits, I believe, that we achieved in the upstream areas may have been negated in the delta. So
How long of a pulse, with your proposal, how long of a pulse would it take to have this phenomena